That was scary. That was like penny.
Oh! There we go. So, dy dx. You guys read it to me. What's the rule?
Bottom to top. Yep. Back.
Holy cow. Yeah, sometimes.
Leave it just like on this. Do you get it?
Okay, we could take it to the man if it was a long answer. If it's a multiple choice, I promise you that's not it. So what would you do?
Distribute.
Pause!
No.
Look and see. Is anything in common between the two terms?
No.
Alright. So distribute. So we have 4x squared minus 20 minus 8x squared minus 2x. You guys agree?
Yes, ma'am.
Some of you tried to do factoring, but it didn't really work.
I pulled out a 2. Oh, I mean a negative 2. Plot the negative 2.
Yeah, but you can't factor any more than that, right?
Yeah, that's true. But
so, yes, you can pull out a negative 2 if you want, but there's nothing that will simplify.
Oh,
so.
shoot, I did it.
Well, I tried.
Now pause really quickly. Did you kill a seal?
Killed like everything.
I didn't.
No!
No, I did.
Okay.
My seals are intact.
I believe in animal life. It's fine.
Yeah, bottom be top. Like the quadrant rule, second be first. Go with the farther and then the quotient. Alright, okay, so quotient rule, we have it written down. I need you guys to make a forever card out of it. Now pause. Forever card number 12, right? Is that where we are?
I think
It's going to have 2 parts to it. Cut it in half, and on one side you're going to put the product rule. On the other side you're going to put the quotient rule. 1 card, 2 rules. 1 card, 2 rules. I did have some kids from period 6 today say, when's the forever quiz? And then they started whimpering, because I guess tomorrow and Friday are bad days. I don't know. Something's going on. Something's going on tomorrow and Friday.
I said let's do it on Wait, is it
So, it was supposed to be on Friday. Listen, it's okay. Ashley Garrett and Naomi and Abby and I don't know who else, whoever was over there was like, no, please, we're not going to be ready this week because there's a lot going on. There's a lot of formulas. So, it's going to be next week, probably the end of next week. Instead of having 2 forever quizzes this chapter, we're just going to have 1 with all of the rules at the end. But what do you need to be doing?
Memorizing.
Well,
Now, are you technically studying every time you use it in a problem?
Oh, yeah, you're getting it.
Yeah. So hopefully as we do more problems, you'll get them even more ingrained. But just keep in mind, there's going to be a lot of rules on the next forever quiz. It is not this week out of consideration to you guys, but it will be coming. This is forever card 12A. Why? This is half of it. Forever number 12A. This is half of it. 1, remember, on one side, product rule here, quotient rule here. Okay? Quotient rule will be the other half. There it is.
So is it going to be for the forever quiz that we're going to take? Is it going to be all of them or just the ones that we learned?
The regular credit, like the regular points, will be from the new cards that we went over since the last quiz, which would be 6 through wherever we stopped, because the first quiz was 1 through 5. But bonuses will come from the old cards.
Okay, so just have
So is it smart to study them all? Yes.
All right.
But you especially need to have memorized the new ones. Does that make sense?
Okay.
Okay. So 12A and 12B, product and quotient rule, they are both on the card. And all the different notations, but on a quiz, the most times that I will make you write it, what am I going to say? I won't make you on a forever quiz write all 3 representations, but I could ask you for 2. So you need to choose which representations of the product and quotient rule you prefer. Figure out your top one, your first one, your most preferred, but then also know at least 1 more.
Quotes 12.
Maybe, we'll see.
Yes, let's get it, Warriors.
All right, so, Tyler, did I answer your question?
oh, well, just like, are we going to have to know, like, the square and,
You get to choose. You get to choose.
you know?
So I'm saying know at least 2 representations. If you know the first and second, you're fine, but you get to choose. All right, cool kids. Real quick, I don't think we need to take too many notes on this, and it actually has already shown up in homework, and we've already talked about it. But if they do say something like, find the horizontal tangent line. Wait. Didn't we already find this derivative? X squared plus 1 x. Oh, bummer. It was so close.
Oh.
All right, let's go ahead and steal this. It's 4x over x squared plus 1 squared. Let me change the sign so that this one is the exact same. So in our example, it was minus on top, plus on bottom?
And squared both of them, I think.
Okay. Minus on top, plus on bottom. Just to make it simpler so we don't have to do another example right this second. Squared. Okay, is that good?
Yeah.
All right, so this one we did just a couple examples before. I think it was the last example we did yesterday. And we found that f prime of x, double check me, but isn't it 4x over x squared plus 1?
Yes.
Squared? Okay, so that's what we found yesterday with the quotient rule. If they ask, find when or where the function has a horizontal tangent line, what have we talked about with horizontal tangent lines? What's true?
Derivatives are 0.
Slope is 0, which means the
Derivatives.
derivative is 0. So if I'm setting this equal to 0, question, how do I set a fraction equal to 0 and solve?
You would
Think multiplying the denominator, what happens?
Zero.
So I only need to look at, technically, the numerator. So the only 0 is going to come from the numerator. The denominator has DMEs, or undefined. More presents. But when does or where does the graph have a horizontal tangent line?
You do the sweet action and the clumsy drops. What a combo.
Okay, you guys got it? Horizontal tangent line set the derivative equal to 0 because the slope is equal to 0.
But is that x?
No,
In this
just
one.
because the algebra.
But why is it not a y if it's horizontal?
Well, because it could be at like 0,5 or 0,4. Remember, it just needs to curve at that point, or curve at that point.
Oh.
But that
Oh,
point
so it's
could
like-
be,
Okay,
yeah. Okay, so at x equals 0 is the place where that horizontal tangent line occurs. Okay, what else? Woo-hoo-hoo! Trig! Who stopped in trig last night on their homework?
I got to it and I did my problem.
Sweet, can you tell me what number? What number does the trig start?
It was
30 something?
That's like a hard one.
yeah, it was
I think it's
30, 45.
Close. Okay, so 45, the trig starts. Let's make sure we can do the trig. For those of you that got up to the trig last night, great job. For those of you that started, great job. For those of you that didn't,
Good job.
have fun tonight.
Okay, I will.
Because that's spot check tomorrow. It's okay, Tyler has a gov test and a physics test today, so we understand. For those of you that just have gov tests,
Okay, but really, if Tyler didn't have these tests, he would still not have
he's been doing pretty good. He's been doing better than pre-calc.
Yes.
He's doing better than pre-calc.
I think everyone's been doing better than
In pre-calc or then pre-calc?
and pre-calc.
Yeah, I feel like the nice thing in calc is that we do narrow down to those that are more committed, right? So hopefully you guys are encouraging each other in the sense of staying on top of things. Now, hold on, pause. If you're one that you're such that, I feel like I might be losing some commitment, losing some speed, trying to get lazy, wanting to get lazy. Maybe you need some accountability, huh? Maybe you need a friend in calc to be like, hey, can you check on me and make sure I'm doing my work? That's a life lesson too. We need that in life. We need that in our walk with the Lord. We need that in our any good commitments that we're, any good resolves that we're trying to do, right? We need someone to check up on us from time to time, because what happens when we don't have anyone checking up on
We
us?
slip up.
Yeah, we get lazy, right? I get lazy. Same thing. If I didn't have progress reports and grading periods, yeah. But I do, hence why your grades are totally up to date. Yay, go team.
Wait, did you put the best version?
Yes. All right, derivative of sine. Review. What is it?
Cosine.
Derivative of cosine is?
Negative sign.
Negative.
Do you have to like do sine over cosine?
Ah, that's a great idea, because what is tangent?
That's what I had to do for.
Rewrite.
That's what I did. And then I did quotient rule. It took a
Rewrite.
little while.
Yeah, that's probably normal.
85.
The question, doesn't quotient rule apply with whatever's being divided?
Yes.
Yeah, so we can do it with sines and cosines too. So, the derivative rule would be bottom, cosine. What's the derivative of the top?
Cosine. Negative. Wait.
Oh, no, you're right.
Yeah.
Whew, where was I going? I don't know. Minus, top, derivative of the bottom.
Negative sign.
Wait, is that a negative?
Boy, it's a lot.
No, it's a
All
positive.
over.
I started writing negative, Steven, that was my
It's a
bad.
lot uglier than just being like.
Derivative of sine is positive cosine.
Number 45. And I wrote it all out.
Wait a minute, over bottom. Can I do cosine squared? That's cosine of x
Yes.
squared, right? Don't get tricked by the trig notation. What's cosine times cosine?
Cosine squared.
Well, I did that wrong.
What's sine times sine, negative times negative?
Positive sign.
Plus
so it's
sine.
There you go.
Cosine squared
Is that
plus
one?
sine squared is 1!
That's,
Oh,
What's
it
the
is.
last
Oh.
Square?
Wait a minute! 1 over cosine squared, who's the reciprocal of cosine?
Secant. So secant
Ah,
squared
it's the
x.
same thing as secant squared.
Oh my gosh, there's rules.
Dun 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 dun. Yes, the derivative of a tangent will always be secant squared. Why?
Because we proved
Quotient rule.
it. We proved it.
Quotient rule. And cosine squared plus sine squared is just 1, and the reciprocal of cosine squared is secant squared.
We don't need to do work.
Wait a minute, last year, pause. As long as we memorize making a forever card. Pause, last year. Wasn't there a formula that related tangents with secants?
Yes, there was.
Oh. Could this maybe be a reminder to me that tangents and secants are related in derivatives as well?
Does
I have to
do
remember
with it,
how.
right?
Has nothing specifically to do with it, except for the fact that this came from a result of dividing sine squared plus cosine squared by cosine squared. Tangent and secant have the exact same denominator. And that is the reason why the derivative is what it is as well. Because tangent is over cosine, secant is over cosine. That's why they're related in the derivatives as well as in the Pythagorean property. Now, question. What other two properties besides sine and cosine were related as well?
Cosecant and cotangent. Are we right, O?
So what would you guys think, just guessing what the formula of, or the derivative of cotangent is?
Okay, I want to say that, but I feel like there's a
I know,
negative. I
there's
feel like
no
there's a
way.
negative cosecant squared x.
Why would you think that? Well,
good.
let's go ahead and rewrite it and see if we're right. So, define ddx of cotangent. Now pause. How many of you have memorized the derivative of sine and cosine? Derivative of sine and cosine. Okay. How many of you think you're going to have that memorized pretty soon? Pretty quickly. Derivative of sine is cosine. Derivative of cosine is cosine. Okay. Couldn't we find these derivatives if we ever forgot?
yeah.
Even on a forever quiz. If you forgot which is which, couldn't you do the quotient rule real fast and check?
Yes.
Yes. Because the over cosine squared goes with secant squared, and then this one, I'm going to have cosine over sine. Maybe you guys realize I am going to have over sine squared in just a second. Let's see what happens. So, bottom is sine, top is cosine. So bottom d top, sine x times, derivative of cosine is negative sine, minus top, cosine, d bottom, yeah, it's going to be the same as same. All over bottom squared. So I have negative sine squared, minus cosine squared, all over sine squared. I can't quite do my Pythagorean, I have to pull out the negative first. So maybe Sean was right.
Yes!
Because if I pull out the negative, now I have sine squared plus cosine squared, which is 1. So I'm going to have negative 1 all over sine squared, which is a cosecant squared, but with a negative.
What does that look like?
Wait a minute. What's the derivative of cosine? Okay. Here, sine. What's the derivative of cotangent? Negative cosecant squared. So maybe the derivatives of any cos have negatives?
That seems like just a coincidence.
Derivative of cosine, derivative of cotangent, derivative of cosecant. Partially, but partially. Yeah, I say partially because coincidence. Like it's how the math works out, so it's not a coincidence per se, but that's true. So, do you think we could memorize derivative of tangent to be, derivative of cotangent to be? Yes. Wait, tangent and cotangent, are they somehow related? Does it make sense that maybe their derivatives would be similar as well? Tangent, cotangent, sine, cosine. The derivative rules are very similar when dealing with a function and its co-function. Something to keep in mind. But what functions have we not dealt with? Sine, check. Cosine, check. Tangent, check. Cotangent, check.
And the squared ones, yeah. I use the squared, for the squared ones, could you just bring the power down?
No,
No?
that's half
It's
of
two
it.
functions?
Chain rule. You have to do times 8 times. Cosecant, who is he? Rewrite.
1 over sine x.
Secant, who is he?
cosine of x. Cosine. Okay,
Cosine,
so,
cosecant.
so bottom, d bottom is top, d bottom, all over bottom squared. But we,
Yep.
but it'd be 0.
Yeah,
Yeah.
but that's okay, still write it, because bottom d top, that is going to be a sign. Derivative of 1 is just 0, right? Minus top d bottom, all over bottom, which is going to be negative cosine, all over. Why am I rewriting sine squared as
So
sine
that you
times?
can pull out
So you can-
cosine over sine,
yeah.
which is cotangent.
Because I have I can think of it as a 1. I can think of it as a 1 over sine and a cosine over sine. What is 1 over sine?
Negative. Oh, it's cosine.
I have a negative. 1 over sine is cosecant. And cosine over sine is cotangent. Wait, didn't we just talk about how cosecant and cotangent are related?
Yes.
Okay. Now this is a little weird. Derivative of cosecant has a cosecant
That's weird.
times a cotangent.
Why? Okay. Sure, but like.
So, cosecant
Stop.
has quotient. Cosecant has 2 parts.
I mean, secant's probably.
Now, technically cotangent has 2 parts too. It's cosecant times cosecant. We just call it cosecant squared. So all of the more complicated derivative rules have 2 parts to it. Just for cotangent, it's cosecant times cosecant, or cosecant squared. And for cosecant, it's cosecant and cotangent.
So this.
No, it is rough. It's hard to memorize. But wait, pause. Do you know the derivative of sine? Everybody, what's the derivative of sine?
Cosine.
What's the derivative of cosine?
Negative sine.
Couldn't you always just do quotient rule if you forget?
Oh, yeah.
Always.
I bet you the next one is positive.
Ooh, Nathan is making a bet.
Positive secant.
Okay.
What's the other bet mean? So donut
X
holes?
tangent of x.
If he wins, he can have donut holes next Wednesday. If I win, I get donut holes next Wednesday. Okay.
Both of you will have them anyway.
So that's what we think it is. Do you guys agree? What do you think?
Because the negative cosine would be, or the top. I mean, it would, okay, yes, I thought about it.
So the negative sign.
I think I got it.
Let's see. So bottom be top. Let's see if he's right.
Oh, I got
If
you.
you're not,
Yeah,
he
negative.
was gonna get the.
Bottom, cosine, d top is 0. Derivative
Top, the bottom.
top, and then d bottom is negative sign, right? Ooh, a negative times a negative is a positive. All over bottom squared. So we have positive sine. How am I going to rewrite cosine? Yeah, cosine times cosine. So 1 over cosine, sine over cosine, was he right? 1 over cosine is secant, sine over cosine is tangent. Do the trig rules have patterns when derived? Yes. But who are similar? Sine and cosine. Who are similar? Secant, tangent, no. Sine and cosine, tangent and cotangent, secant and cosecant. A function with its co-function. Sine, cosine, tangent, cotangent, secant, cosecant. But, once you're taking derivatives, derivative of sine is?
Cosine.
Derivative of cosine is? Derivative of tangent is?
Secant.
It is sine or cosine quotient
Tangent
rule.
is secant.
But secant squared. Secant squared. Derivative of cotangent is
Negative.
negative cosecant squared.
Cosecant squared.
What do you think to do that?
Bless you.
You feel like throw the squared out whenever you say tangent.
Whoa.
Throw the squared. It's gonna be secant squared. So tangent, cotangent, throw the squares. Secant, cosecant, they don't get a sign. They're lame. Derivative of secant, secant, tangent. Derivative of cosecant, negative cosecant,
Is
cotangent.
she empty?
Hold on. So when do you throw the squares?
The squares are
Throw the squares when you have tangents. Getting tan at the beach and throwing out squares. There you go. Getting tan at the beach and throwing out squares. Now, when you go to the beach, don't throw out gang signs. That's bad. But if you're getting tan at the beach, throw out squares.
Why?
No.
Yep, forever card 13.
Oh no.
Oh.
Two cards tonight, we're doing good.
Go team.
Do we have to have all of these memorized?
I love that you actually asked.
Like the thing is, I know them, I just...
Well, pause. Didn't I just say?
Yes,
You can
you
make
did.
this sine over cosine, cosine over sine, 1 over sine, 1 over cosine, and do the quotient rule. But that takes
forever.
time. So if you can try to memorize it, then you can save time. But if you're not sure of your memorization and you get stuck or you get to a problem or you get to a forever quiz and you want to make sure you're right, what can you do? Quotient rule, right? You can do quotient rule. This is forever number? Oh, not 12, this is 13.
You said 13 the first time.
Oh, I did?
No, this is 13.
I heard 13.
It was 12.
This is
It's
13.
12A, 12B.
This one's 13.
The prior quotient rule is 12A, 12B, this one's 13. If I said it, Denise, you're my hero, thank you. I thought 12 at some point.
You know, Jeannie's 5
It's
in
not
the
my fault that you
video.
guys don't listen.
5 in the video. Who's it?
I was listening.
Not sure it really matters that much.
Mystique, is there a separate like document in the drive that has all of them forever?
Yes, but I'm updating them as we go, so I don't think they have 12 or 13 yet, just because each year it changes a little bit. Like forever 6 with the horizontal tables. Woo! Ready, set?
Here we go. Let's go nice.
This is homecoming!
Can you go back?
Oh, sorry.
10 next to the
No one knows about that.
Anyway, what first colors?
What's the first one?
cosine?
You try to do both, huh? Both sides.
What's the derivative of sine again?
I feel like this is nice when this is
Cosine.
Cosine, what?
Wow, my notes last year were so ugly. Like, I didn't even like looking at them. That's
See,
what,
now it's nice.
yeah,
Look at you go. You have good writing, like.
yeah.
I just love making notes, but I always mess up.
Alright, let's get it.
Mystique, that one doesn't need.
Take your forever, your notes to college, go tutor some people and make money. That's what
Whoa,
George is doing.
how much money?
If I get excited.
Ooh, short.
It depends. If you get hired by the college, there are frequently colleges that hire students to be like TAs in math labs, because almost every college has a math lab for kids to come get help. And you can literally just sit there and do homework, and if some kid comes, help them, and if
That's
not.
what Offer did.
Yeah, it's a good one. They don't pay you as much as private tutoring, but it's also consistent. You get so many hours every week.
Like,
Here at Anderson, she now works for
That's just who I
NASA,
am.
actually, but she did it at CSUN. She did that and she did private tutoring. She made quite a bit, and it was great on the resume.
You get that money.
She works at,
Get your payday.
what does she do at NASA? I don't know, she's in like the computer programming.
You tutor courses.
How many shots?
But that one would probably be like maybe 12 to 15 bucks an hour. We can also do homework while you just sit and wait.
Due to this parabolic phone.
If you do private tutoring, I think Georgie's making like 20 bucks an hour. That's a good place to start as a college student.
I'll help.
If you get like a Baptist degree, you can probably charge 30 to 35 an hour, depending on, if you're in North Dakota, don't charge that, but
I need tutoring.
in LA, probably.
I have one.
Beverly Hills, I had a friend who was making 75 an hour.
Oh.
Beverly Hills.
That's a lot.
I didn't have
You
this
guys
client.
want to learn French?
I still
I
charge,
tutor on Mondays.
I charge like 15 an hour for calc.
I
I only had like one student a couple years ago. I just don't have time to do it much anymore. But then I charge like 40 for like geometry, algebra 2, that sort of thing.
That's a pocket change, that's good.
The kid needs it more. He just asks it like once, right? Like every time before a test, so it's once every 2 weeks.
That's your deep.
But. Anyway, I'm not just necessarily preparing you for your future career. I'm also preparing you for maybe some pocket change, right? Kids always need help in that. All right, you guys need a derivative?
Yes.
I know how to take math in college.
Not necessarily. But you want to stay on top of it, so if you are going to tutor, probably start pretty quick.
But I have to learn a little.
I'm better.
It's like-
It's, in high school, you don't make a
I
lot.
definitely
You can make maybe like 15.
I didn't even like that.
wrong.
I didn't go far.
They teach us
In California.
I just like chemistry.
LA is different. All right, you guys ready, right?
What are you mad about?
No more life lessons for right now. 5x to the negative 2 plus sine of x, right? Could you have done quotient rule? I suppose. But couldn't you have just done a power rule?
Dude, that's not fair!
No, it is! I'm showing you before you get on a test.
You're gonna fail the AP test doing that,
Can you
dude.
explain that?
Pause. Could quotient rule,
Well, that's actually really cool.
could quotient rule have worked?
Yes.
Yes.
It works.
Bottom D top minus top D bottom all over bottom squared. It works. But what did I do? I said this is 5. I could pull the 5 out. 5 times 1 over x squared is 5 times x to the negative 2.
Okay, this is.
Remember, we can rewrite a denominator as a negative exponent?
Yeah.
Now it's just a power rule. I can make it negative 10 x to the negative 3 plus cosine of x
Yeah, is that
equals negative 10 over x cubed. Now pause. What if you look, because hold on. What if you keep going and you didn't need to? How would you know whether or not you needed to keep going and simplify?
The multiple choice
Look at the
answers.
multiple choice answers. If it's a long answer, you could have stopped here and taken the derivative. But I'm assuming it's a multiple choice. We're trying to simplify. What if you look at all the multiple choice answers and all of them have the addition of 2 separate? They solved it this way. They took the derivative of each one separately. They did not, well, I guess even if you did quotient rule, same thing. And you could stop there, but what if you look at all the multiple choice and they are all, well, either there's a couple separate but it doesn't match up with yours, and then there are a couple that is one entire fraction over x cubed. What did they do? How could they make it one fraction? Yeah, so look at the multiple choice. Before you keep going, maybe you could stop. Maybe this is an answer. Maybe this is an answer. Get an answer that you know is right. Look at the multiple choice real fast and be like, ooh, I need to keep going. I need to simplify. So see if the multiple choice have negative exponents. If so, sweet. If not, okay, I gotta keep going. That's a way to save time on tests rather than still going, and the answer was way back here somewhere. Okay, so if I multiply by x cubed over x cubed, the or could be negative 10 plus x cubed cosine x all over x cubed. So this one is right, but so is this one. Look at the multiple choice to help guide how far to simplify. Does that make sense? Similar to if you plug into a quotient rule, and if, like in the one that we did at the beginning of class, you guys could have factored out the negative 2, but you probably needed to look at the answers first before going that extra step and taking extra time to write down an answer. Look and see, are any of these factored? No? Okay, sweet. Does mine match? Ooh, all of these are factored? Oh, I have to keep going. Use the multiple choice to tell you when to stop. Tyler?
So the math is really pretty easy for these so far, but if we ever get to a point where taking the derivative of something would be like this huge mess in a quotient rule, could we just kind of leave it all in like ddx of function and then all do a math blob at the end? Like, do you know what I'm saying? Like for space sake?
We're just doing a first derivative right now, a second derivative?
Yeah.
For a multiple choice?
Well, no, for a long answer, like, because
Oh, long answer, you plug into the rule and you stop and you box it. Unless they need you to use it to solve for like the zeros, then you have to simplify, or else what are you gonna do? But if it's literally just find the derivative, which to be honest, besides my tests where I'm building you up to FRQs, on actual FRQs, it's probably not gonna be just take a derivative. There are some just take an integral, but we'll see that when it comes. Kiddos, can I do the same thing to this and do a nifty little power rule with the denominator? No. I can't separate the x squared from the sign. This is one big denominator. I can split up numerators, not denominators, so this is stuck. The only option I have is quotient. So I tricked you on this one a little bit. Some of you did quotient rule, but you should have ended up at the exact same place. Sean, did it work quotient rule?
Oh, yeah, totally.
Yeah. No stress.
Yeah.
No stress. But this one, no choice. So we have bottom and we have top. You guys gonna help me out?
Top.
Okay, hold on. Write F prime. Get in the habit of labeling it at least once. You have to show the transition from F to F prime in your head. Kind of like writing limit over and over again. So bottom. Bottom what?
Top.
What's the derivative sign?
Cosine.
Good. Minus?
Top.
Because it's quotient rule. Quotient rule has a minus, right? Product rule has a plus. Good. So bottom D top minus
Top. Bottom.
D bottom. They sound Jamaican if they
Bottom
try.
square.
Wait, you didn't even derive that.
Good. Could that be a common mistake, just get in the rhythm and not really think about it? Careful getting familiar with the rules. be careful getting familiar with the rules. Top, d bottom, so 2x
Plus cosine?
plus cosine x.
Oh,
All over
Oh.
bottom squared. If you need, just
On the
double
top,
check,
you'll find-
bottom d top minus top d bottom, all over bottom squared, good. It's time to simplify.
Okay.
It's time to simplify. First things first though, look at these two, does anything match? It's rare, but every now and then. All right. E for effort. Oh wait, look, I can cancel this guy out, right? I got one. No. What I just killed.
You killed so many things. You killed animals.
I can't just randomly cross out stuff if it's
Go
not
4 for
factored.
animals.
There's a minus, I cannot cross out things like that. It has to be shared.
Science.
No, we can't factor anything.
No.
Come on,
Cosine x will cancel out.
It will eventually, right?
Yeah.
So I'm going to have x squared cosine x plus sine cosine minus 2x sine x minus sine cosine. You gotta distribute that minus, don't kill a seal. Yeah, nice, right? Sine cosine, there's a positive and a negative.
It's still pretty nasty.
She's not fun though.
She's not fun, but it's okay. The multiple choice answers wouldn't be fun.
What if it's easy?
Well, I disagree, math is fun.
Math is fun.
X squared cosine x minus 2x sine x.
I don't know why you want to do it.
Now, if I was a college professor, I would not say the following statement. They would say the basis or the basics of calculus is all the theory behind why it works, behind the limits, behind the epsilon delta proofs. They would say that is the foundation. Those are the basics. But I would say for our purposes in AB, the basics, as far as the basic skills I want you to have and I need you to have and the AP needs you to have, are the basic derivative rules. They form the foundation for the rest of the year. Now, are limits important? Oh, yeah. And are the AP guys going to test you on limits? Graphically, algebraically, even with some derivative definitions, but the basic skill I need you to develop are your derivative rules. And what have we seen so far? We have forever card number 10, the basic derivative rules. We have forever card number 12, product quotient rule. And now we have forever card number 13, trig rules. Those are the basics. And I need you to have them down. There's only one rule we're missing. It's called the chain rule. We're not going to cover it yet because it's in a new section, its own section. I think it's 2.4. There's one last thing I need you guys to see. Do we need to solve that one?
Nah, that's what we need to see.
I don't think so. Let me go ahead and move this to the end. This might be something after your homework that we need to go ahead and talk about, so let me just move that one to the end. All right, the last big idea is higher derivatives. Let me give you guys a second. In this chart down below, you don't necessarily need to write them all. You don't necessarily need to write them all. But what do you already hopefully kind of know the notation for? Y prime, F prime, dy dx, or d dx of f, or, this is a snazzy computer way of saying it, d sub x of 1. This is the first derivative. However, there are things called higher ordered derivatives, meaning you can take the derivative again and again and again. You can keep taking them up to a certain point for most functions, or for polynomials at least. Polynomials, there's a limit. Most other functions you can keep deriving until the cows come home, aka forever and ever and ever. But that doesn't mean you always need to keep taking derivatives. And all the work we've done so far, a first derivative is what they were asking for. They only wanted us, first derivative, to take the derivative once. A second derivative says, take the derivative 2 times. Third derivative, take it 3 times. Fourth derivative, take it 4 times, aka take the derivative and take it again, and take it again. I would say there's not much application for a fourth derivative, don't even bother writing that down. But
Because it just gets 0 eventually.
the fourth derivative, maybe it's helpful because for a polynomial, yes. But for other functions, sine, cosine, you're just gonna go back and forth and back and forth and back and forth. Leibniz notation says take dy dx, which is, I think Tyler, you pulled this out before. D dx of y is dy dx. Maybe you can see where that notation comes from. But if I'm taking the derivative twice, I'm taking d dx of y. So maybe that makes sense. D dx is d squared over dx squared of y. D squared y over dx squared. There is no squaring going on. There is no cubing going on. There is no fourth powering going on. It's notation for higher order derivatives. Meaning, what if they ask me to find a second? I have to do the deriving process twice. And notation, think Roman numerals. We do 1 tick mark. 1 tick mark, 2 tick marks, 3 tick marks. We would call it F prime, F double prime, F triple prime. Double prime is second, triple prime is third. But then we don't say F quadruple prime, that's awkward. So then they do start actually using, for 4th and 5th and 6th, they do start using little exponents to help us. What does it mean? Take the derivative, but then you take it again, and take it again. And you'll see a couple of those in homework. Guys, all we missed, I think, were examples. So 2, 3, I want to see it fully attempted tomorrow. Doesn't mean you make it all the way to the edge. But you've done your best. You've solved the large majority of it, like 90%. Bye, guys.
You don't have to. Where's my?
Bye, kiddos.
No, I'll probably just. Misty, 2 things. Cameron left a ruler which very well might be yours.
I even asked, I said, anybody who wants to use it, Cameron's looking. Why? Alright, ask me later, come in and during lunch after school.
Misty, Cameron left the back, which very well might be yours. Or it might be his.
Oh yeah, that is mine, I think so. He borrowed it for